Hello, everyone. Thanks for tuning in to this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza, and it's one of my great joys to really bring you these conversations each week or so that we have with just so many different innovators, creators. We're just building such cool stuff, really inventing stuff that is just new ways of doing things. We talk about cloud native, we talk about Kubernetes, DevOps, platform engineering, observability, security, all of this good stuff. And it keeps getting exciting each week. I'm excited about today's conversation as well because it's not too often we talk about this topic, but it's definitely something that definitely needs more discussion and more coverage. And I'm really excited to be talking about it. It's around serverless computing. That's going to be our topic for today. And yeah, we're going to be talking about WASM, using that. And we're going to be talking to one of the innovators in the space. They created this cool open source project that is now part of the CNCF. It's called Spin. We're going to be talking to Matt Butcher, who's the CEO of Fermyon. Matt, it's great to have you with us.
Yeah, thanks for having me. I'm excited about today.
All right. Yeah, second time around we're having Fermyon here, but it's been a while. I think it's been like over a year, maybe 2 years or so, since
Yeah.
Fermyon came to talk about. So a lot has been happening since then. So really excited to hear what's new, what's exciting, what's on your mind. And really looking forward to hearing what's happening even on your customers and what do you see, what do you hear as you speak to them, what are they building, what are they doing, what challenges do they
hmm
face, and how are they navigating those challenges. Those are the kind of things really want to hear from you, and really excited to have you on the show. As we get started,
Thanks.
bro, if you could give us a little introduction to just your career thus far and just your path to Fermyon.
Yeah, sure. I kind of stumbled into software development early on in my career. I had intended to be a philosophy professor, by the way. Got distracted by the fact that I needed to pay the bills, and ended up sort of getting into content management systems. Was a Drupal developer for a long time. Joined HP to work on their Drupal platform back when they were working a lot with Drupal, and that was how I discovered cloud computing. And really, I mean, the moment I saw cloud computing sort of in action for the first time in this sort of highly experimental environment inside a very, very early HP cloud, uh, I had this sort of like fundamental shift in the way I looked at the world. I had always sort of just assumed that you'd have this one-to-one relationship between a piece of hardware and its operating system. And suddenly it was like, oh, you can run all these operating systems, and not only that, all these copies, and not only that, but you can lease them out in trusted ways to other people. And I had this moment where my career path just sort of instantly shifted over, and I went, I don't want to do CMS anymore. I want to do cloud. So I've been working in cloud technologies for decades now. Worked early on HP Cloud and then OpenStack, and then into early container technologies and on into very, very early Kubernetes work. And this whole trajectory kind of pulled me farther and farther along, and is actually what got me into WebAssembly as well. We started Fermyon with this idea that WebAssembly actually might be the kind of third class of cloud runtime sitting alongside of virtual machines and containers.
Uh, Neat story, man, amazing. And yeah, really interesting that you're into philosophy. I want to ask about your favorite book later. That's behind there. Um, but yeah, getting into our topic for today, serverless. Uh, and even, something that's very related is edge computing as well.
Mhm.
Just wanted to get into that and get sort of like an introductory like a thing to set the context, a sort of
Yeah.
a use case or an example of what do organizations deal with when it comes to serverless and edge computing. What are some of the things that they need to get done? What do they come to serverless for? What are some of the use cases and some of the challenges as well that they face? If we could get started with just setting
Yeah.
that context, that'll be great.
I think serverless as a programming paradigm sort of entered our collective consciousness around because of Amazon's Lambda service, right? So, and it's actually a lot of fun to talk about what Amazon was trying to do and how that's
Mhm.
transformed over about a decade into what we need to do now. Because Amazon basically, was in the business of leasing virtual machines, right? Just like I was talking about with HP, it was what was so exciting to me at that time. And they realized that they
Mhm.
had spare capacity, little chunks of compute that were not being used. And so they invented a new kind of paradigm for software developers to follow. And it was, they called it Lambda functions, right? And the idea was, as a developer, I write just a little small piece of code. It takes an
Mhm.
event, it takes an HTTP request, starts up, does something, returns a response, and shuts down. And so instead of being a long running server like we were all kind of building at the time, it was serverless in that there was no real server infrastructure there. No, you weren't writing code that started up a long running process that was going to handle hundreds of thousands, millions of requests. You were writing just an event handler, just one tiny piece of code. So Amazon's doing this going, well, we got some spare capacity. We could use up that spare capacity and make some money off of it by providing this to users. And of course, it took off. So much so that Amazon had to completely rewrite how they were doing it. And then Google and Azure and all the other big cloud providers got into it. And then it became sort of a standard way of doing stuff. It worked its way all the way out into edge computing, which we'll talk about quite a bit today. But essentially, what they were doing was saying, okay, no longer is it the case that we're filling spare capacity, right? We now have this is such a popular service that we have to dedicate capacity to it. And this is what got us super interested because, at the time my team was working at Microsoft, we were looking at where we could optimize cloud computing. And what we discovered was these serverless solutions had gone far away from their origins. And what they were doing at that point is there were so many inbound requests that in order to start up virtual machines fast enough, they had to
Mhm.
pre-warm everything, which meant they had a gigantic queue of hundreds of thousands of pre-warmed virtual machines. And a request would come in and they would drop a piece of code on that pre-warmed virtual machine, execute it, return a response, tear down that entire virtual machine, spin up a new one, put it on the end of the queue. And I hope that dollar signs are sort of ringing in people's ears as they hear this, right? Like, you don't
Mhm.
want to be running stuff in gigantic queues, just sitting there consuming memory, consuming CPU, consuming, all your vital resources so that it can work fast enough when the requests come in, right? It's a tremendously wasteful system. And so we looked at that
Mhm.
system and went, okay, there's got to be a better way to do this. One that perhaps doesn't require having huge amounts of compute resources just sitting on standby, but instead can be a lot more reactive. Something that really was trending back toward what AWS's original goal was of saying, hey, we've got a small amount of spare compute. How do we reuse it very effectively? So,
Mhm.
effectively, we got now a definition of serverless, right? A developer paradigm where you're just writing an event handler that takes one HTTP request or one request, regardless of the format, does some churning, returns a response, and shuts down. On the other, we've got this old kind of archaic system that is not necessarily meeting the economic needs of the modern organization, right? Or to put it more plainly, it's just really wasteful, right? So he said we want to keep that first part because developers tell us over and over again that they love writing serverless functions this way, but we need to tackle the efficiency problem. So
Mhm.
as we got going at Fermyon, we started looking into the right way of doing this. And the kind of aha moment for us was, okay, first wave of serverless functions were built on virtual machines, but virtual machines are optimized to run for long periods of time and at the
Mhm.
cost of a very slow startup. And that's introducing the problem.
Yeah.
Containers, too, are designed to run for, hours, days, months, whatever, quarters without restarting. And so and also they have a pretty good performance penalty for getting started up. So we've got two cloud technologies that are great for running server-like workloads, databases, a long-running REST API servers, that kind of thing. But maybe what we need is a third kind of class of computing that would be optimized for running things that needed to start up, handle a request, return a response, and shut down. In other words, maybe we needed a specific kind of runtime engine for serverless style workloads. And we started
Mhm.
looking into what kind of engine that might be. And that was what ultimately drew us to this technology called WebAssembly. And for those of you new to WebAssembly, it was originally invented to run inside of the browser, right? This was a technology that was invented by Mozilla in conjunction with, and you don't hear these words very often, in conjunction with the Google Chrome team, the IE team at Microsoft, and the
So, yeah,
and the
browser war,
Safari team at Apple. Yeah,
everyone
exactly.
coming together.
Yeah. And so they built this technology to basically be a neutral runtime that would run inside of the browser, and you could compile code to WebAssembly's binary format and run it in the browser. There are use cases where things like the classic Microsoft case. There was an old Excel library that they needed to run inside of Office 365 when they were building O365. They didn't want to rewrite that library in JavaScript. They wanted to compile the C version to WebAssembly and then use JavaScript to interact with it. Or in the case of Figma, they hit performance limitations with JavaScript's mathematics, right? Computing capabilities. And they do a lot of vector-based images. So they wanted to build something in a high-performance language like C++, I think is what they chose, compile it to WebAssembly and run it in the browser. So this whole browser environment was about a secure runtime with high performance and that could start up and shut down nearly instantly. And those were the three metrics we were looking at on the cloud side. We're like, we just want a secure environment with great performance numbers that can start up and shut down effectively and supported a whole bunch of languages. WebAssembly was the technology. So as Fermyon got started, we focused on building two classes of tools for serverless development. We'll talk about both of these today, I think. On one hand, you got developers. They need a tool to build their applications. We built this tool called Spin. On the other, you got to have a runtime environment to be able to run these kinds of systems. So more on the DevOps or system platform engineering side of things, right? And that's where
Mhm.
we talk about things like Fermyon platform for Kubernetes, and more recently the work we've been doing with Akamai to be able to run these kinds of serverless applications all the way out at edge. Um,
Wow. Um, One interesting thread that connects Lambda and WebAssembly is that they both were kind of accidental inventions or out of necessity, or
yep.
they were not intentional. That's really interesting, though.
So so much of our history as in the software world is like we built a thing to do this and somebody else said, "Oh, well, we can do that." The World Wide Web was built to trade physics papers, right? And now we use it for everything from, watching movies to reading the news to playing games. And probably the physics papers are the vast minority of traffic on the web.
Yeah, yeah, but really interesting tracing of history there for us. That was a little history lesson. We should never forget, I think, where things came from, and there's always something to learn
Yeah.
from the origins. Um, and I like also that you kind of separated as well the development from the running of it, the ops and the platform side. Really clarifies things as well for our discussion. Uh, so talk about some of the challenges with just running serverless, doing edge computing.
Mm,
Have you seen any, what are some typical challenges, some, disasters or some things that just your
yeah.
your customers grapple with as they, use serverless in the real world?
Yeah, and I think this is one of the things that's exciting about getting to come back a couple of years later, right? When we first talked about this, we were talking about, some very straightforward use cases like server side of, static site running static sites, running small API servers and things like that. But man, the world has kind of changed in the last few years, and we have definitely seen sort of the emergence of some very interesting use cases. I mean, early on, and I think we talked about this at a KubeCon a year or so ago. We had this customer come in and say, here was my problem, right? We are a large manufacturing company, and we got a new customer, and this new customer drives so much traffic, so much data into our site that it's changed our profile for how we have to run things. And they were really experiencing this transitional moment from server-based computing to serverless computing, right? They had a Kubernetes cluster with a lot of long-running containerized applications that consumed a lot of memory and a lot of CPU time. They had to reserve a lot of CPU, and it was running all the time. And what they were dealing with was as that new customer drove more and more traffic into their Kubernetes cluster, they were having to expand their cluster more to be bigger and bigger and bigger and bigger and have more and more resources allocated. And that was expensive. And so
Mm.
for them, they looked at serverless as a cost optimization and said, if we
Okay.
switch from these long running, always on kind of applications to ones that could kind of start up, react, and shut down as demand sort of ebbed and flowed, then that would be a much better way for us to do things. So it was exciting to come alongside them, discover that we could cut their Kubernetes cluster size back by about 40%, just by being able to be more reactive. So that
Hmm.
was an exciting case of like going from server bound to serverless, long running containerized processes to short, nearly instantly running WebAssembly ones. But things changed even a little bit more. The rise of AI has really changed the way we think about things. And for a long time at Fermyon, we were looking at AI as like, okay, well, how do we provide AI services? But a new case has emerged for us, and again in conjunction with Akamai here, that is kind of a baffling unintended consequence of the rise of AI, and that's that these bots are now just flooding into sites. And so on one hand, recently Akamai published some numbers that showed that there are now more bots on the web at most times of day than there are humans. And
Wow.
we're
Okay.
just seeing this.
That is staggering.
Right. Yeah, I mean, it was
I haven't,
I did a tour of their data
yeah,
center and they're showing real time, right? This
that's
is not the
crazy.
web I thought I lived on, right?
Yeah.
um,
Wow.
and I
That's
think
quite
that is, AI has enabled us to basically write tools that digest all of that information and do interesting things with them, but it's a huge influx of traffic. And frankly,
mm,
not all of the bots out there are doing good in the world, right? It's become much more easy for bad actors to use these kinds of bots to do things that are definitely sketchy. And there's this
mhm,
whole new gray area of like, how do you deal with intellectual property? And if I publish a story or publish some pictures out on the web, I don't necessarily want that material to be used to train bots. And so we have
mm,
sort of discovered the flip side of the AI thing. Like early on, we do a lot of work in inferencing. We provide a lot of AI tools. We have plenty of people who are using that kind of technology. But now we're starting to shift focus a little and say, what can we do, particularly at the edge, to write
mhm.
serverless applications that prevent bots from doing
Oh,
things to your site that you
okay.
don't want them to do.
Really interesting.
Yeah, yeah. And
Yeah.
so Akamai has a service that does really, really good bot detection and can say, "Hey, warning, this request you're receiving right now came from a bot." And we've
Mm,
started getting into, working with a number of customers to say, okay, when that happens, what do you want to do to protect your content? What do you want to do? Do we need to rewrite? One of the common cases that really stretches back decades now is, competitors scraping pricing data off of each other's sites.
mhm,
So if we detect a scraper bot that's coming in to try and find out your prices so that they can undercut you, we can write
mhm,
a quick serverless function that says, okay, we're going to dynamically intercept that request. We're going to rewrite the pricing data. But the AI stuff has gotten much more interesting. And we
okay.
actually have been working on this one recently where the customer says, hey, so we have content that is our intellectual property. We don't want an AI bot to crawl out to consume that content and train their model on our intellectual property. But we
Yeah.
do want the AI bot to know a lot about us so that it can drive traffic back to our site. And this, I think, is a
Okay.
case that is going to be really emerging in SEO technologies, right? We want our content to show up in these bot generated things, but we don't necessarily want the LLMs to train on our content. And so what
Mm,
we ended up prototyping now, and I'm hoping for when this goes into production and I can start pointing people toward it, is a system where when we detect an AI crawler is coming in, we actually use an LLM to dynamically rewrite the content of the page so that the
okay.
LLM gets served a variant of the original content, maybe like a summary or a bullet list or something, enough to train it that this is an authoritative source on the information it wants, but not enough to give away the data that's used for training. So we're definitely
Wow.
seeing a sort of Yeah, right. I mean, it's like this is not a thing I ever would have thought of 4 years ago. And now this is a case that, multiple customers are saying this is something we need to protect against. So it's been fascinating to watch that happen. And then another
Really?
case that's come up a couple of times this year is, Edge has gone from sort of a luxury item where you've got your main cloud running somewhere, and then the big companies have edge computing available to them, and they use CDNs and they use things like that. Cloudflare, Fastly, Akamai, all of these big edge providers have made it much easier and much more affordable for everyone to avail themselves of edge technology. And consequently, as these technologies have gotten more sophisticated, you can do more at the edge, right? Gone are the days where edge meant CDN, right? Now edge means, everything from bot detection to running serverless functions to caching content to resizing images, all kinds of services. But an outage then, because we've gotten so used to having the edge, an outage can be fairly catastrophic. So another thing we've been looking at quite a bit in the last year has been to be able to run Cloudflare workers inside of Fermyon functions so that Cloudflare had a couple outages this year. Can very easily pick up the load at Akamai, for example, or run these inside of your own Kubernetes clusters and just have failovers into your Kubernetes cluster and make it much easier for people to have peace of mind that they can deploy one function and have it run everywhere. And that, by the way, is sort of an interesting inversion of the WebAssembly story we started with, right? Because for us, we chose WebAssembly because it was so portable and because we could say, hey, here's a technology that's not going to have vendor lock-in associated with it. Now what we're discovering is we can take some technologies that did have vendor lock-in associated. Cloudflare workers are a Cloudflare specific system, but we can compile those workers into WebAssembly and then run them anywhere we've got a WebAssembly runtime. So it's been kind of a surprising virtue of the WebAssembly runtime that we can actually unlock people who were previously kind of locked in to particular ways. But I think, that's three stories right there that kind of paint a broad picture of how
Yeah.
Edge now has changed so much from what Edge was even when we started Fermyon, 4 or 5 years ago.
Wow. Yeah, just so much there. I think we could even have like spend our whole time just talking about those three things and dive in deeper. And
Yeah, yeah.
so much to talk about just there. Um, but yeah, really interesting. Just wanted to dig into just two of them, just briefly, to talk a bit
Mhm.
more. Sounded really curious about what you mentioned, cutting Kubernetes infrastructure costs by 40%, just by going from long running to short running
Mhm.
instances. Just give us a bit more details there, because I'm guessing that, some who are listening to this may actually be thinking of that. How do I cut my costs, or
Yeah.
how do I make it more efficient? So to talk a little bit more about just the kind of use cases, how do you think about that? Where can you actually reduce? How do you go about this whole reduction? Give us a bit of detail
Mhm.
there. Yeah,
Yep.
let's talk about that.
Yeah. So, as many of you know, Kubernetes is a kind of core technology to me. I've been a huge fan early on. Built Helm, the package manager for Kubernetes, worked on early Kubernetes. And the reason why it was so exciting to me, and the reason I continue to be excited about it, is that as an orchestration layer, it just makes it so much more manageable to be able to run a host of services under sort of one control plane. But it was built very specifically to run containers, right? And the idea was you start up one, three, five, seven, whatever instances of a particular service, and it's usually three at least, right? And you have it running in your cluster and it's spread out across nodes and it's relatively resistant to outages. But the con side of that is, well, you're running three copies of your application, and consequently, you're pre-allocating enough memory and enough CPU power and enough storage and all of that to manage not the minimum load and not the average load, but really the max load that you could expect to come in because you cannot scale up fast enough in Kubernetes to be able to real time take a huge like Black Friday size influx of traffic and then scale back down dynamically. And we've tried a whole bunch of ways to manage scaling of containers inside of Kubernetes
Mm,
with greater and lesser degrees of success. But our
mm,
kind of intuition was, well, part of the problem is that we're just writing everything as long-running servers. We have these API services that get called a dozen times a day, and instead of writing a long-running server that's always going to be on just in case somebody calls to that API service, what if we figured out a separate way to run inside of Kubernetes these serverless workloads? So we built a technology called SpinCube, and we built this in collaboration with SUSE, Liquid Reply, Microsoft. We all kind of worked together to solve this stack of problems that allows us to run WebAssembly side by side with containers inside of a Kubernetes cluster. So, roughly the way we did it is down at the container D layer, the thing that schedules and runs the container. We discovered that we could write a plugin with that system that would also let it schedule and run a WebAssembly workload. So that was the first piece. The second piece was, well, we could then describe WebAssembly serverless functions the same way we describe containers as pods and then as deployments and all of that. And so we could just sort of build this analogous system that worked seamlessly inside of Kubernetes using all the same things you're used to using. But instead of running long-running processes with it, you could basically say, when a request comes in for this app, that's when you invoke the WebAssembly serverless runtime, start it up, run it to completion, shut it down. So suddenly you can have these services that are available all the time, but aren't actually running unless they're actively handling requests. And so, the earlier attempts to do things like this in projects such as Knative, they ended up, at the end of the day, requiring very long-running container processes that used a lot of memory. And were actually very complicated to maintain over time. And again, this is largely due to the work we did with Microsoft and SUSE and Liquid Reply. By figuring out how to plumb this all the way down to the container layer, we removed a whole bunch of the overhead, which meant now it's really, really efficient to run, but without much operational complexity. Platform engineers are largely just approaching it the same way. You can write Helm charts that do this. You can actually run a container and a pod a container and a WASM function side by side in the same pod because it's all plumbed in so thoroughly. So that's the SpinCube project for us, and that's another CNCF project under the Spin framework in CNCF. We built an offering on top of that called Fermyon Platform for Kubernetes that took that core idea and replaced one kind of key piece with a technology we're really excited about. That instead of running, one WebAssembly application per, container D started spin instance, instead said, hey, all of the applications can be scheduled onto one runtime. So what that means is, say you got 3,000 serverless functions. I know that's a huge number and well beyond what most of us would run in production, but say you got 3,000. You don't want to have 3,000 separate WebAssembly runtimes. You want to have one WebAssembly runtime that can listen for all of those 3,000 applications, execute each one securely, and be able to, respond back in milliseconds. So again, if we're talking performance, it takes about 10 to 12 seconds to start up a container. It takes 1/2 of 1 millisecond in Fermyon Platform for Kubernetes to start up and execute one of those functions. So very, very fast technology. And that's the kind of thing where once you've got it, and developers start writing those serverless functions instead of long-running servers, then you can really begin to cut down your cost of ownership, because instead of needing enough space to run dozens and dozens of containers side by side, suddenly you're just saying, hey, only need to handle this case where we're running some serverless functions that are only going to be consuming memory and consuming CPU resources when they're handling a request. So we can, the technical term for this is we can vastly improve the density, the number of things we can run per chunk of CPU, per chunk of memory. And that's what SpinCube and Fermyon Platform for Kubernetes do.
Wow, really interesting and great explanation there. Also, I want to clarify regarding this thing you mentioned about the LLM wars that are here. Just want to ask, probably that as well is on some people's minds as well right now, very relevant, and probably I didn't know they could actually do this. So is this something that Fermyon actually enables as of now, or is this an upcoming feature or release? Is it possible right now?
Yeah, so we introduced serverless AI about 2 years ago, but the use case was different then, right? So the idea was I write a function that says, hey, I need to do this particular inference operation. and you can kind of write it, run it, test it, and locally run it on even on your CPU or on your local GPU. And then when you deploy it, the deployment system would say, okay, this function is going to need some GPU resources, and it manages scheduling the GPU and everything for you. The original goal for that was to make it very easy for serverless developers to begin using LLMs. And we built a kind of cool scheduler that allowed us to time slice GPUs, to slice up a GPU and allocate tiny fractions of a GPU for like milliseconds in order to handle these serverless functions. Because again, the difference between a long running server process is it'll start and a serverless function is a server will say, hey, for as long as I'm running, I need this chunk of GPU. It always has to be available for me in case I get an inferencing request, and it basically locks down your GPU. In the serverless world, you say, okay, uh, this function's only going to be running for about 20 milliseconds. So it only needs 20 milliseconds of time on a GPU. And because it's just doing an inference, it only needs like 1/50th of the GPU, right? And so we built this system that allowed us to schedule GPU kind of that quickly. And with the intent of really unlocking developers who wanted to run their own LLM models. That was a couple of years ago, but things have really sort of morphed over time. And in particular, as we've started to work more with Akamai at the edge, Akamai started rolling out GPUs only about a year and a half ago. And so we've been able to use a different class of GPUs that are scaled down and that are distributed over the Akamai network. But effectively, the primary situation is kind of the same, right? We allow you to write applications that use your own GPU, your own LLMs, and that are sort of allocated within the Akamai realm, and be able to very quickly do inferencing on those. The use cases are what have surprised us, right? Because what we were thinking people were gonna do was build chatbots. Now here we are a couple of years down, and what we're seeing are fairly sophisticated uses of LLMs to do anything from product personalization. This one, I just think this is super cool. Take my particular, I don't know, Amazon buying history, right? Be able to read through that and come up with not just a custom list of products, but product descriptions that say things like, hey, Matt, you bought a navy blue polo, 6 months ago. Here's a pair of pants that would match those really well. And you bought or a dog toy that says, in the previous times you've bought dog accoutrement that indicate your dog is about this size. So, here's a dog toy that's just right for a 25-pound dog, that kind of thing. And it's exciting to see AI sort of begin to morph in that direction and be able to do something that is interesting, because and this case is actually more interesting than it sounds at face value, because we know where AI fails, right? AI does not do really well in cases where super high factual validity is of utmost importance, right? They're language remixers. We get sort of hallucinations. We get weird responses. We get basically the aggregated wisdom of Stack Overflow and Reddit, which is probably not what most of us consider to be the most authoritative source on many things. And so because of that, it's the high accuracy tasks that are scary in AI. But low accuracy tasks are where there's a whole bunch of good room for greenfield, right? If an AI algorithm recommends a polo that's not my favorite color, does it impact me adversely in life? No, not really. But if it surprises me with a polo shirt that I really like, then suddenly I'm engaged in a buying experience that I wouldn't have otherwise engaged in. And so it's areas like that where we're starting to see AI sort of creep in. And so as we built this system, the usage has stayed largely the same, but the problem space is different. I mean, we gave that security example earlier. Here's one that is very helpful in the commerce world. We built one recently to show at a big Wimbledon event that allowed you to kind of type in your favorite tennis players and see when they were playing, where they were playing, if you could get from one court to the other in time. What will happen if these two win and get paired up, and it's those kinds of things that are just fun. Right. The fidelity and importance of them being accurate is moderate, but the added utility you get from them is where you really kind of, wow people, where you really kind of get people excited to be using that technology.
Wow. Really interesting. The language remixers. I like that way of describing them.
Yeah.
Um, as you were talking about the kind of stuff you guys work on behind the scenes to make these workloads, these use cases possible. The thing that came to my mind that keeps repeatedly coming up in the things you say is, uh, you know, speed and efficiency. I feel like these two things
Mhm.
really are very central to how you look at infrastructure, how you look at enabling these use cases, and that less is more. And it seems
Yeah.
like, you have this mindset that you always keep thinking of what can I remove? How can I strip this down to the very bare essentials that we need? And I think that kind of thinking is something that, anyone who's dealing with these kind of use cases and challenges, thinking of AI, thinking of reducing Kubernetes costs,
Hmm.
enabling more edge edge computing applications, and just thinking on these lines, I think that's the kind of culture you need to have in your teams, and even that's the kind of thinking you need to have about less is more and what can I remove to move faster. Wouldn't you say that that's something really fundamental to what you do?
Oh yeah, absolutely. I think we've kind of taken a two-prong approach where we've said, on one hand, we want to start simplifying the developer's experience to build things, right? And reduce the amount of work they have to do. And on the other, we want to reduce the expense that the operations team, both the expense and the complexity that the operations team has to swallow in order to run something. Uh, you know, Computing has gotten awfully expensive. Cloud computing, the costs just keep going up and up and up. And at the same time, we keep asking platform engineers to learn more things, developers to learn more things, and the tower starts to get tippy at some point, right? And that's where we think simplifying on really both sides of that is kind of key. And I think of the things that are most evident to the end user, it's probably how easy it is to build the applications. But the things that are sort of the most evident to us, the things that we're really the most proud of, are those performance characteristics, right? Getting cold start
Mm,
times down from hundreds of milliseconds to half of a millisecond, getting density, up to where we can run literally tens or even hundreds of thousands of serverless functions per installation of Fermyon platform. Those kinds of things are just the things that I think we are the most proud of. And the reason why is because the efficiency thing is coming for us and we want to be well out in front of that. We need to start looking at ways to cut the cost of operations, cut the amount of power we're using, the number of chips we have to buy, but at the same time, not have that degrade anybody's performance or reduce their ability to build the kind of applications they want to be able to build.
mhm, mhm. Yeah, yeah. Wow, really cool. I want to ask about a name that's been coming up multiple times in your responses, Akamai. So yeah, you have an integration with them, and seems like they're kind of like giving you that edge computing global
Mhm.
network layer. Talk a bit more about this partnership, why it is so important, why you chose Akamai, and yeah, just how it's going with this integration.
It's actually a perfect segue from performance because we're compute nerds, right? I mean, at the core, Fermyon is a company that is full of engineers who specialize in compute. How do we shave milliseconds off of execution time? How do we gain just this much more memory efficiency? And we built
Mm,
this platform that we were very, very proud of because it was so fast and could run at such high density. And just about the time we're thinking like, okay, we can take the victory lap, it dawns on us that compute is only half the story, right? We built the world's fastest serverless runtime. And it's easy to show it in performance tests. But the problem was uh, if you can get it running in half a millisecond and you still have 300 milliseconds of network latency, you're not actually solving anybody's experienced problem, right? They're still waiting for the website to load. And so, we had built Fermyon Cloud. In fact, that was, I believe, the last time I was on here was just right after we had launched Fermyon Cloud. Great developer
mm,
experience, great
mhm,
execution speed, but we're not a cloud infrastructure company. We didn't know how to run an infrastructure that was going to be flexible enough to get people the network performance they needed. So even as we
mhm,
built a very fast platform, we were still getting, in many cases, 300 milliseconds of networking time. And as we looked into it, we said, well, we can't build the kind of network we need to run this, right? All these companies have so much of a lead on us. I mean, look at Akamai. They've been around since the 90s. They have over 4,000 points of presence in the world. There's no way we could. And then it sort of dawned on us that, wait a minute, maybe we could work with Akamai, right? We could provide something that their customers want. We can, and then we can, take advantage of this vast network. And so, we approached Akamai. They're fantastic, fantastic group of engineers that we were just, I mean, for those of you who don't know, like Tom Layton, the guy who started Akamai, literally worked down the hall at MIT from Tim Berners-Lee, the guy who invented the World Wide Web. And Akamai was the result of a brainstorming session between these two guys. And it's just so cool to find a partnership there. So we've been working with them now since March of this year. And we're taking kind of a phased approach with what we do. So they have multiple kinds of data centers. They have some that they would call core or distributed data centers that are large ones with large amounts of compute power available in which we can run Kubernetes. And then they have all the edge nodes that are much, much smaller, very svelte, but very fast, and are spread out all over the world. And so we began rolling out into their core zones a while back. And this gives us coverage of, most of the world at this point, from, Australia to Brazil, to North America, to Europe, to Asia, and gives us this great coverage map just with the core regions. And inside of those regions, we can run large Kubernetes clusters that can handle millions and millions of inbound requests of traffic per second, right? So it's like just absolutely, this was not a thing that would have been within the realm of possibility if we had continued trying to go it alone. But by simply partnering up with Akamai, who has this global footprint and some fantastic compute power, we've been able to move that direction. Earlier this year, maybe it was late last year, Akamai announced that they are going to be able to run workloads, smaller workloads, all the way out in their 4,000 points of presence. And so we've been working with them early on prototypes of that, where we can actually deploy just the WebAssembly runtime to these edge nodes that are running all over the place, and then have the Kubernetes clusters that are operating slightly more centrally, right? It's all very decentralized, but slightly more centrally, be able to schedule workloads out all over. And we had this great experience where we're in London testing things out and going, we're getting like 7 millisecond round trip times with all the network and everything, right? So send the request, do the computing, return everything back, because it turned out the point of presence was like less than a mile away from us. So we were like 2 network hops away from it. And it was just one of those moments where we're going, we could provide this experience to customers around the world. It would be phenomenal. So our excuse me, so excited. So our partnership with Akamai has really focused on being able to take advantage of their delivery network in order to run WebAssembly serverless functions really as close to the end user as possible. Now, there was sort of one unintended additional advantage that I already hinted at earlier in telling the bot story, and that's that Akamai doesn't just have a network, right? They have CDN services, they have bot detection services, they have object storage services, all the things that developers want to be able to hook into to build really robust sort of edge native applications that are designed to be able to run in their entirety on the edge. And so, the kind of unintended consequence is now we can build things like, the LLM bot protection kind of tooling that can prevent bots from flooding a site or training on people's intellectual property and things like that. So in addition to just being able to solve the problem we thought was the core problem, can we compute at the edge, we can now sort of solve a far more sophisticated set of problems that, like I was saying earlier, we didn't even foresee as being things people would want to be able to do. And now we're recognizing that that's where probably some of our best opportunities are.
Wow, that idea comes up again. Just
Yep.
unexpected outcomes. Really
Yeah.
fascinating.
Yeah.
Um,
Yeah.
we're almost out of time. We probably won't get to be able to do the demo today itself that we probably had planned, but I think, yeah, we should probably have you back for a part 2 down the line. Uh, but there's one important thing that I wanted to definitely talk about before we end, though, which is Spin, the
Ah,
Spin
yes.
frame that you contributed to the CNCF. Just tell us a bit about it. Yeah, the recent updates and just any thinking
Mhm.
behind it. What would you like people to know about this, the Spin project?
Yeah, and this comes back to that kind of duality I talked about earlier, right? Runtime is important, developer tool is important. Spin is the developer tool for building these kinds of applications. And the idea is, in 2 minutes or less, you should be able to go from blinking cursor to a deployed application. It's just a workflow tool to streamline building WebAssembly binaries, building components, all the things that would be hard if you had to do it on your own are just designed to be very easy inside of the Spin system. We recently, I mean, I guess I say recently, it was early this year, we contributed Spin to the CNCF. The point of doing that was we'd already had a lot of contributions from Microsoft, from SUSE, from many other contributors inside of the WebAssembly ecosystem. We really realized at some point that shared governance along with shared code contributions was what was going to be necessary for Spin to really actually realize its potential as the best serverless development tool for WebAssembly out there. So after going back and forth on whether it was going to be Bytecode Alliance, the WebAssembly organization, or CNCF, the cloud organization, we chose CNCF and have been quite happy with that. And then we're just releasing Spin 3.4. So we're well into the Spin life cycle at this point. 3.4 has some really exciting database upgrades, some really exciting HTTP2 upgrades, and we're continuing to work now on building a tool that integrates well with your AI coding tools as well, so that you can get the benefits of the WebAssembly ecosystem along with the benefits of code generation assistive technologies that are all the rage and for very good reason right now.
Mhm, mhm.
If you want to take a look at Spin, spinframework.org is the site that has the CNCF project. But of course, you can always get from fermyon.com to any of the things that I've been talking about today, whether it's the Akamai thing or Spin, or libraries of things you can build on your own. But Spin is that developer tool, something we're very proud of. Sits at the core of Spin Cube, the Kubernetes runtime. Sits at the core of Fermyon Wasm functions, the Akamai runtime, and sits at the core of Fermyon platform for Kubernetes. So it's really a foundational piece of technology for us.
Mhm. All right, all right. Wow, that's really good to know that Spin is in good hands and that development and the progress
Yeah.
it's happening and it's getting better. We're almost at the end. I was just wondering if we could just do a very short version of the demo, just maybe the hello world. Like how long would that take? Would that take like 2, 3 minutes
I
or
just said it
so?
would take 2 minutes or less, so now I'm really on the spot. I think we could
Okay.
probably
All
we
right.
could probably do that.
If we could just do that part, it would really, be a great ending to our conversation.
Okay, all right, let's do it. Can you see my desktop here?
Yeah.
And should have a console there. So I'm going to do a spin new command and just create a new app called Hello World. It's going to create a new directory called Hello World, um, because I just ran it off screen. You did so. I'm going to cd into this Hello World directory and open VS Code. So you should see VS Code pop open here in a moment. There we go. So here's my new Spin project. Spin scaffolded out all these directories for me. Inside of here is I chose a JavaScript application. You can do Rust, you can do TypeScript, you can do Python, Go. You can mix and match and do multiple languages, but let's go with the easy one here. So I'm going to create a new one that returns hello universe, is the default one there on the slash path. So let's go ahead and just build that out and try running it. So I'm going to do a spin build, and I'm going to do dash dash up to start a local version for me to test out. So this is going to drop all the way down into the node package management system, build out the JavaScript core of it, then compile the JavaScript into WebAssembly, build me a little binary, and then start up a local service for me to test. So behind the scenes, what we're seeing here is it's going all the way out to NPM, doing all the package installations. And then in a moment here, we'll see it's starting to do the compilation of WebAssembly. And what I end up with is a nice little binary file that's portable across any of the WebAssembly runtimes, but particularly the Spin family of them. So I'm going to close Copilot there so I can see my terminal. And I just accidentally stopped my command there. There we go. So we've got our URL here to localhost. I'm going to open that up inside of Safari here, and there I can see my hello universe right there. So that gets us sort of the development cycle. We could go back and edit the code if we had a little bit more time and do something else. But the kind of cool thing is from this point, it's super easy to deploy this to a Kubernetes cluster using spin K8s deploy, or we'll deploy it to Akamai using spin Aka deploy. And with one command, I can push it up. And what's happening right now is it's going out to our Akamai control plane. It's getting distributed to all of the installations of Fermyon platform running throughout the Akamai network. So we'll get, a little bit of time here because it's really deploying all over the place. And then we'll get back a URL and be able to test that live as it comes up on the internet. So handles everything from generating the SSL certificates to global traffic routing of the DNS entry to the closest region to you, and all the way down to the spin runtime. So it's actually really cool platform that's doing a lot behind the scenes, a lot of orchestration that if we were to do this manually would require at least an afternoon, sometimes a couple of days to be able to do. And here it's going to take still a couple of minutes, but it's a couple of minutes of just waiting instead of time actively setting things up.
Mhm.
So what it's going to do right now is it's registering a new domain name. It's creating a new SSL certificate. It's going to give me back a unique domain name that I can open up in my browser and see just that same hello universe message.
Okay.
And while that's going, we can quickly look through the code and sort of see what's happening here. This is just a function, right? We literally have a router that says, here's how you match our path to a particular response. And that's all that's really getting executed. In this case here, this is the top level binding that's saying for when a request comes in, this is the thing to start up and respond with. So that is really actually the sum total of code that we're writing.
All
I
right.
think while that one's running here, I'll show you really quickly. This is the kind of content rewriting that we've been doing. So here's the kind of case where we want to protect against scrapers that are going for pricing information or perhaps for images that are being used to train LLMs. And the system we built here basically inserts a proxy between this page and the bot. So when a user is detected, it takes us to this page, and we see the t-shirt and the price and all of that. When a bot is detected, it reroutes into a proxy that's dynamically rewriting the page. And so what we see here is it detects where the price is and it redacts out the price. So the pricing scraper can't see it. It detects the t-shirt, redacts it out with a generic gray image, and prevents an LLM system from being able to see it. And essentially we're using Akamai's bot protection at the front end to detect that, and then humans get directed to this version of the site, and bots get directed to this proxy, which is dynamically rewriting everything sort of on the fly. So
Wow, pretty cool.
I think where we're at here is the deployment is taking longer than I thought. So we can give it a moment and see if it completes. Usually the process takes less than 1 minute. But of course, during any kind of demo, it usually takes more, right?
Yeah.
And while that's still going here, so spinframework.dev is the site you can go to learn all about the spin environment. This is what it looks like here. You can go through and see all the various triggers and all the various, how to work with various databases. And of course, Fermyon.com is the site that's sort of the top level. You can dive into the development resources here. One thing I particularly like is if you're just trying to figure out sort of what to build, the Spin Hub has all kinds of demos, basic starter templates, the kinds of things that you can use to get that first project from zero to deployment.
Right. All right. Wow. Yeah, really cool. Uh, yeah, that's some really interesting stuff. I loved all the things we talked about. It was really quite an interesting conversation. We touched on some really fundamental concepts behind computing today. And I think that was really exciting in the conversation. And just your approach to running serverless and at speed and at scale is really fascinating. So just a lot of takeaways. It's definitely something that, people are watching, listening to this. If this has been on your mind, you want to, build these kind of apps that are, really fast, really performant, and run really efficiently with minimal costs, then definitely check out what Fermyon is doing. Go read up their website and check out all of the work they're doing with Spin, and try out their integration with Akamai as well. Sounds like a lot of capability there, and even stuff that's around the corner that they're just releasing even as we speak. So lots happening, lots of exciting stuff. Go and check out Fermyon if any of this is interesting. Um, with that, we'll probably bring the conversation to an end, and maybe you can do an extended demo the next time you come on. Uh,
That's
but
right.
yeah,
Yeah. Yeah.
this was quite a whirlwind of a conversation, and we touched on so much. So thanks so much, Matt, for joining us. It was a real pleasure chatting with you.
Yeah. Thanks for having me. Yeah. This is a lot of fun.
All right, and thanks to all of our listeners and viewers as well for tuning in, and we'll see you on the next episode.